Okay, today we're talking tangents, and our mission and our objective is to find the equation of the tangent that goes right there, touching at that point. Now, we don't know what that point is, but we do have a clue on how to find that point. But first, let me go through the steps that we're going to use in order to find that equation of that tangent. Step number one is we're going to go straight into that point. We're going to find where it is. And the clue in the question is that it crosses the x-axis. So we're going to be able to work that out. Then after that, we're going to need to differentiate this curve over here. Now, it's not in a very useful format for us to be able to differentiate. So first of all, we're going to put it in a differentiation-friendly format, meaning we're going to expand it so it's easier to individually take each component and find the derivative. Then after that, we're going to substitute the x value right over here into the derivative, and that's going to give us the slope function, which we are going to come up with the actual slope or the gradient of that exact point. Now that we know that what the gradient and slope of the tangent is, all you have to do now is put in the 2-point formula, the equation, substitute the x and y value with that slope, and we're going to have the outcome, which is the equation of the tangent right there. So now we've got the visual diagram here displayed there, and we're going to have the algebra here so you can get a clearer perspective and gain more clarity into how this all works. So let's begin at the first step, and that is to find what that point is exactly. Now, because it's cutting the x-axis there, we want to know where the curve cuts through there. We know that it's going to be what for the x-axis? It means that's when y equals 0. That's essentially the x-axis. So if y equals 0 and we look up here, how do we make y 0? Well, isn't it true here if x equals 2, the whole thing will be 0? Because 2 minus 2 is 0, so therefore x will need to be 2. Now there's our point. Let me put it in a friendlier format. 2, 0. That's the point right there. That's where we're going to get the equation of the tangent. So now let's expand this, as I mentioned earlier, so we can put it in differentiation-friendly format. So let's multiply out. So y equals x times x squared is x cubed. X times 2x squared. And then we just continue. Minus 12. 2 times 6, 12, negative. Okay, let's see what we can cancel here. There's a bit of cancelling. We have a plus 2x squared, we can cancel that. And a negative 2x squared, we can cancel that. Now, let's see how we can further simplify this. We've got here x cubed, so our y equals, and we've got 6 minus 4, that's going to give us 2x, isn't it? And finally, we have the minus 12. Now that's interesting, that minus 12, because that's going to give us where this actually cuts the y-axis. Now it cuts the y-axis when what? When x equals 0. So when x equals 0, that's going to be 0, that's going to be 0. We're left with negative 12. As you can see, there it is cutting right there at negative 12. Okay, so now that it's in this format, we can differentiate and find the derivative easily. So let's do that now. Y prime equals, or dy dx if you prefer, it's going to give us 3x squared plus 2. Now, what do we need to do with that slope function is make it equal what? It's going to, actually no, we're going to substitute the x value in there. So let's substitute the x value that we want. Which x value? It's when x equals 2. That goes in here for us to find the slope and gradient. So at x equals 2, right there, it's going to be, let's call it f prime 2, that's going to equal 3, 2 squared plus 2. And that's going to equal 3 4s are 12 plus 2. 2 2s are 4, 3 4s are 12. That's going to be 14. So that 14 is the slope and gradient at that point right there. Now 14 is rather steep, so it looks like it's kind of like going like that. And let me just mark it up in there so we can have a good look at it. There it is right there. That's the tangent there, and the slope of that tangent is 14. Nice and steep, almost vertical. So now the next step is, now that we have that, and we have the x and y, is to find the equation of that tangent. So we're going to use the 2-point formula. So that'll be y minus y1 equals mx minus x1, all in brackets. So all we have to do now is substitute in there. So we have y minus, and y1 is going to be, here's our x and y, 0, which equals m, which is 14. Let me just put that in there. X minus, and our x1, of course, is 2. Okay, let's further simplify this. So if I further simplify it, that's going to be y is equal to 14 x minus 2. Now that's our equation of the tangent, and that's right over there. So let me just write it up here next to it in red. And we just copy that down, y equals 14 x minus 2. And there you have it.